Today, I will talk about the second module of cloud computing, an introduction to cloud computing service. I give a brief introduction about cloud computing service. We talk about data storage as services. Then we talk about cloud computing operating system. The last one, we discuss application software services. Finally, I give a conclusion. Cloud computing allows users to support their business, store data, and use cloud services without investing in new infrastructure, training new person, or license new software. In other words, we don't need to set up the computer center to do all these things, like buy the hardware, software, training people, maintenance, this equipment and software. Many different ways to store data through the internet have been explored, from sites such as Flickr, which allowed us or users to access a photo anywhere, to email account, which serve all users incoming and outgoing messages virtually with no loss of the user's hard disk drive space. Examples of current cloud storage and service platform are Amazon S3 and Nutanix. Actually, also include IBM, Microsoft, a lot of companies provide the cloud storage. This service provides storage and services managed by third parties for a fee based on need to store, retrieve, and upload content. Let's talk a little bit of data storage service, right? First, what is storage as a service? We use STAS. Remember, you have T, not SAS. Storage as a service allowed users to store data at remote disks and access them anytime from anywhere. Users' data is stored on remote storage systems that are maintained by a third party. This data is then accessible through the internet, which is the connection between the client computer and the databases. I visited one huge data storage center in Minnesota. You will see a lot of building, a lot of computer and data storage. They call the data storage center. They use a lot of power. When the first time I saw it, I was shocked. The cloud-based storage system show how the cloud connected the user to their stored information through a web application that allowed the basic user to create, store, and file all the information choosing. This is just one example of diagram, give briefly cloud-based storage, how it works. From here, we can see application can be any application such as we are student, right? Want to log into the Amazon cloud, just example. So you can use a lot of internet command such as HTTP. In this side, we can see a few things. One is the service provider network, right? Later on we talk about operating system, how they balance the workload to different cloud-based service system. So that's the service provider network is cloud-based storage system, right? This is cloud-based storage system that have the service provider DR side. DR represent the disaster recovery. So you see, once you lost data someplace, then you can bring the data back. So they have another piece, right, called other service provider. This diagram give a briefly idea how we can send out through network go to the cloud computing system. The design show where the user works on the application layer, uploading file to the cloud. The software service then distributes the uploaded information to 3 separate storage locations for disaster recovery. The application, which is the web portal or interface to cloud storage, allows users to subscribe to the web cloud storage. Copy of the files that the user submitted are transferred over the internet to cloud storage server. The user then can access their information in 2 ways. Either copy it locally to the client computer or access and manipulating information on the server itself. So in the second case, right, the user can simply has a cell phone or something, you can access information with the cloud computing. You do not need, like, you must have a computer, has certain storage, something like that, right? We talk about here, the disaster recovery side. I know one is typically is IBM provide AS/400 disaster recovery as a service. So they use DRAAS. That's part of data storage service. How we use the cloud storage, right? The users subscribe to a cloud storage service, interact with their data through a web-based interface. Normally we can say API. Files would be sent from the user to the server over the internet, which then record the information. When the user wishes to access this information, a web-based interface or API connection would allow the server to send the file back to the client computer or allow the user to access and manipulate the files within the server itself. A model of cloud storage service integrator was created and published by Storage Networking Industry Association. So a lot of information have been updated, changed. This model shows multiple types of cloud storage interface with a technique that allowed support for legacy and new application as shown in the figure in the next page. That's just one example. It's pretty complicated to show you, right? The first part is client can be in the cloud or enterprise and provide additional service. So that's belong to the first row. You can see a lot of like a block storage client, file system client. You can list more. Okay, this part is really data related. You have a hard data container. That's how you store the data, right? Soft data container. Then you have the database table client. We know Excel more complicated in the cloud computer because they use different database, more complicated. That just give you a brief idea in cloud side. Also, the last part is the client acting in the role of managing data storage, right? You can say, okay, you have cloud data management, right? You have database, or we call data service, right? Storage service, information service. You can see many different ways they use different picture describe data storage service. This is just one of them. I choose to show the idea. Okay, we explain a little bit the previous diagram. Cloud data management interface allows the client to manage and manipulate the data in any fashion as they would be able to if data was stored locally. An example of using SNIA configuration would be for small business web owner. The owner has a laptop and has a strong internet connection. The user log on to the SNIA through Cloud Data Management interface and set up a basic configuration equipped with storage of 1 terabyte to start. You see how big space you can have. Set up a database configuration and backup for all his customers' information. Customer need to pay a monthly fee. The business owner let the service provider maintain his database, storage, and backup recovery for his entire site without pay IT work on his company's name. That emphasizes again, if you use the cloud, you don't need to build up your own server storage area. You don't need to train your IT person. Then you just go ahead and pay the fee, use the cloud system. Here, I used one example, talk about the Amazon S3. It is a storage service. Amazon S3 is a platform that allowed for cloud storage to users on any scale. From, you can see, you cannot say, I use 100 bytes, right? From 1 gigabyte to 1,000 exabytes. This is a huge, huge number storage space. So in other words, it still has the certain requirement for user. Start from certain storage size. To use service, this service client need to, one, we need to sign up for Amazon S3 web service, right? That's definitely, we know that any network or server we want to use, you need to sign up. You need to use Amazon web interface to store and retrieve any amount of data because you use Amazon S3. Let Amazon do the rest, means they help you store the data, back up, increase storage capacity if you need, and if disaster occur, they support disaster recovery. This is just a very brief step, show you the idea we talk about here. First, you sign on for the Amazon S3, you create a bucket, right? What you need, add an object to a bucket, then you view what you want, you move an object, you can delete an object and the bucket when you finish it. This just gives a very brief idea. Advantages of data storage as a service, easy of management. We can, through a simple web browser, right, leaving the service provider to set up and configure and maintain accessibility. Also, cost is effectiveness. Cloud storage eliminates restricted scalability. That mentions scalability again and again when we talk about the advantage of cloud computing. Of the user environment, power consumption, and availability. Low outage impact, disaster resistance. Cloud is prepared with redundancy in storage hardware. Simplify planning. So that's the data storage as a service. Challenge. First, the security. Of course, right? Once we talk about the network, we always talk about security. The same issue for the data storage as service. Data integrity, right? When we talk about database storage data, you must involve data integrity, cost of replicating data. The last one, reliability. My personal opinion, the cloud computing is very, very reliable. Okay, now let's move to the next topic, right? Operating system. Access and use of operating system in cloud computing. Every person in this class, I'm sure you know what is an operating system and what kind of function operating system provide. Now we want to discuss what is the traditional operating system, what is the cloud computing operating system. We can see what kind of additional function cloud computing operating system must provide. So that's we separate here. The first, the cloud operating system provide familiar interface for developing and deploying massively scalable distributed applications on behalf of a large number of users. So not only one entity, probably hundreds or thousands size organization like an entity use one cloud computing at the same time. Exploiting the seemingly infinite CPU. Actually, in reality, you have limited CPU, but because cloud computing connected so much servers make the user fair, you can use as many CPU as you want. Storage bandwidth provided by the cloud infrastructure. Then we look at the traditional operating system, right? Traditional operating systems are used to manage hardware components within the computer, such as the laptop I use now. The cloud relies on distributed processes that manage the cloud resources. That's a cloud operating system. A traditional operating system is a collection of routines. For example, scheduling, right? That's a scheduler. Virtual memory allocator, how distributed memory space. File system code, interrupt handler, etc. You can list a lot. Like I hit the keyboard, the operating system, traditional operating system need to execute the corresponding the service routine called interrupt routine. That regulates the access by software to CPU, memory, disk, and other hardware peripheral, such as the printer, right? Hard drive. What a cloud computing operating system handle this kind of thing? Cloud operating system provide additional set of functionalities. First, give administrative access to resources in the cloud. Second, allocate and deallocate virtual machine. When you use cloud, you want to, let's say, simulate a robot moving. You need to ask a resource from cloud, right? That create a virtual machine for you. You use it like you use your laptop. Then when you're done, you need to release it. When you release it, they need to deallocate resource back to the cloud computing. Dispatch and migrate processes from one CPU to another. Set up inter-process communications. Here, just briefly list a few actually cloud computing operating system provide much more additional functions. A traditional operating system provides a standard library of system calls which program can use to interact with the underlying hardware. Cloud operating system provides a set of, remember, network-based interface that the application can use to curate the management system and control cloud resources. A traditional operating system includes standard distribution of libraries and software packages. Cloud operating system includes software support for the autonomous scaling and opportunistic deployment of distributed applications. So actually more than this. Now, we talk a little bit about cloud operating system configuration based on one diagram. Actually, I can show you, we talk about it based on this diagram, right? The cloud operating system. In reality now, you can find many different diagrams to describe the cloud computing operating system. Again, in here, we, based on this diagram, we talk about the cloud operating system configuration. Cloud operating system consists of the user space and the kernel space. That's in this diagram, they're separate here. This is user space, this is kernel space we talk about here. These two spaces are connected through a network interface and provide a different level of interaction within the cloud. First, look at kernel space. Kernel space regulates physical allocation, access control, accounting, and the management of resources within the cloud space. User space contains processes that are directly used by user, or they call application. From here, we can clearly see this is a network interface. This is the user space. We can have many different applications running, right? We can have the user library. Also, we can have cloud library application interface, right? That's your cloud computing library. This is the briefly user space, right? In the cloud library that gives you can have standard set of distributed system. Okay, we connect the user space and in the kernel space through the network interface. In the kernel space really is the how they can manipulate, support operating system function. Okay, they call kernel cloud process. Provide the cloud-wide resource abstraction and management interfaces. There are these a few. First, virtual machine management, right? You create the virtual machine, send to the user. When they finish it, you deallocate it. You have process management, you have measurement, you have authentication, you can have a lot, etc., etc. They sit in the cloud kernel space. Kernel space, first is virtual machine management is a process to do the following works. Control the allocation and deallocation of virtual machine through the authentication. Kernel access rights are granted to the virtual machine management kernel. Also, this kernel is responsible for mapping an object name with their network address and port number, catching all signals from cloud operating system. Objects in the cloud user space are called and handled through this process. That's the first part in the kernel space, virtual machine management. The next one, distributing process. It provides abstraction and flexibility to computing resource from its physical nodes. It can be done with the use of virtual machine. The second function, support for multiple operating systems on the same hardware. Very important. Support for multiple operating systems on the same hardware present isolation to a certain extent between processes run on a different virtual machine. Remember, when I got my PC logged into the IBM cloud, that created one called a virtual machine for me. Dynamic location on the cloud is done at 2 locations. The cloud process level migrate single processes between nodes, while the virtual machine level use checkpointing, which can restore a virtual machine state on a different node. This is the major function distributing process provide. The next one, access control is controlled by a factor server running on every machine, dedicated to authenticate the user ruling, resulting in a single sign-on facility. So that's the kernel space. User space contain libraries of API, application interface, that can be manipulated and changed to scale the application to satisfy different specifications. Help developers do the following 2 things. First, eliminating the need for a developer to implement his or her own custom library, but instead use the cloud library API and customize them. The second is updating cloud library parameters for different specifications, resulting in reusability of application components. Okay, the third piece, cloud level API provide features for developers across all platforms, failover support with checkpoints, reliable storage, automated deployment, scaling, and lifecycle management. Data replication, consistency, and availability are all provided by the cloud. So now let's go back to the picture. We can see more clearly, right? Cloud user space, what function they provide. Cloud kernel space, that's the key of the operating system, what function they provide. Then it's network interface. So this is just one example. If you go to the internet, you can find many different ways that describe the operating system. How to use cloud operating system? That is very simple. User must access internet and authorize to use the cloud service, right? You create an account, then you log in. The user must log to a portal that create a frame that act as window just like Windows XP. Web operating system combine desktop applications with the web technologies while ignore the maintenance, development, and updating of traditional operating system share. Very simple, log in. Know how to use the application interface, you can do all things with the cloud computing as the software as a service, that level. One example, typically Google Chrome. I'm sure everybody knows how to use Google Chrome. Google Chrome operating system is designed for notebook and focus on using the internet, and the service is provided in order for users to store all their information online. The user can log in to the system from anywhere to retrieve data. Functioning like a web browser, this operating system is essentially what the cloud was designed for, so that users' documents can be written, saved in real time, while collaboration could be streamlined since the update to documents are more dynamic. Advantage of cloud operating system. frame are used. A frame is, everyone knows that, right? When you go to the open the computer, you get the graphic interface, you can create frame. So a frame is a display region of a page. Different frames can display different content from different or the same origin. The use bookmarks, navigation history, or to fill form, cookies, password, and etc. can all be stored on the cloud. API library provide access to cloud objects, distributed reliable service, automated cloud application deployment, and high availability, failover support. All these features relieve stress from the developer where they do not implement their own customized libraries, but can customize their need from the cloud level API library. So, challenge, security, right? Security is a big challenge. We can list a few pages for the cloud computing operating system security related issue. Also, we put all data to the cloud computing data center, how they protect the data. That's the second issue, data protection. The third is implement technology, include access control and user authentication. Security again, right? So I don't think they have any 100% can protect your data. That's why until today, security still is an issue for cloud computing system, include cloud operating systems. Now we talk about the application software service, right? What are application software service? We mentioned this concept in the first lecture. Now we give the detail. Software as a service identifies the use of computing power on a huge scale, such as the cloud, where companies can access applications and a large amount of virtual computing without buying it. The application is hosted offsite by some other company. We know that, yeah, you can use the IBM cloud, you can use Google Cloud, you can use the Microsoft, right? Amazon EC2, many different cloud systems that can be used now. This is a very, very briefly, the diagram choose, try to give a little bit of idea. Sure, the software as a service, this is the architecture, right? If we look at this, definitely this is a cloud service. What function that provide include the function and the data center. What is the us? We are custom. We are use cloud. So that's an application execution request. Cloud is a huge system, not just like an ANT, the server, right? We send a message, we go to ANT. Once you log into the cloud computing, let's say IBM cloud computing, you think your message go to Raleigh. Actually, it's not. You really don't know where they will go. Who will handle it, right? In this diagram, they call cloud service provider mapper. Somebody called the scheduler. Many different names. Right now, according to my knowledge, they don't have a unique name, but they provide same function. They try to match the request I send to their cloud server, which one and the resource storage space, which one is available. that really provide this function. This is the purpose I choose this picture. Very simple, show you the idea. The web service architecture has 3 rules. The first is a cloud provider. It creates the web service and make it available to client. The second is application execution requester. It is a client application that consumes the web service. The third one is a very important part. They call a broker or mapper. Some systems use different names, such as a service registry, provide a way for the provider and the requester of a web service to interact to get the resource. A provider informs the broker about the existence of the web service by using the broker's publisher interface to make the service accessible to the clients. The information published describes the service and specify where the service is located. The requester consulting the broker to locate a published web service. With the information it gained from the broker, the requester is able to bind or invoke the web service. Let's just very briefly explain this picture. This is another one. An example of software as a service architecture, right? Again, you can go to internet and find many different diagrams to describe the software as a service, the platform. So I just choose this one, right? You can choose different one. This one includes 4 pieces. Okay, the first one, let's say at the bottom, is the client application, right? We are here through the GUI, we can put our requests together. That's the first part. We will discuss detail later on. Cloud application. Then this information will be sent to J2EE application server. That's the big chunk here. Okay. J2EE based application, it is the platform. It is an independent. Okay. We also describe it as the Java-centric environment. What it consists, in general, J2E, we can say, okay, it consists of a set of services, application interfaces, protocols, etc. So this is the second part here, J2EE. On the top, we have core application and application wrap service. Application and application wrap service. This is the third part. The last piece, we know where our data will go, right? This is the data database and the data access library. So this is the 4 parts. Part 1, part 2, part 3, part 4. We discuss details how this 4 part works. That from top right, core application and the wrapper service provide the base framework of software used on the cloud. The core provide the core computational library and a function to optimize utilization of the system resources. The wrap allowed the core application library to be integrated with the rest of the system. Communication through Java, the wrap service is scalable and performs the fetching, pre-processing, running, and save data to and from database. This piece. Data and database and data access library provide access to the database as well as access to the API that other modules can use to retrieve and save data. Client application allows users to access the core application and data on the server through a GUI. J2EE middleware application server is the main control of all previous components stated. Its purpose is to retrieve requests from the client application and process the request to where it is needed. So 4 pieces. Client application, right? J2EE application server, core application include the application wrapper, database. Okay, how we use it, right? Software as a service offer usage to customer as a service on demand. Again, when we use the cloud computing, we log in, we configure configuration to create what we want. Software vendor hosts the software as a service on their web servers and disable them after the on-demand contract expires. Software as service suppliers can compete with low-cost services for business to obtain rights to use their software on demand. Example, right? I'm sure a lot of you know Google Docs. Google Docs provide its users the ability to create, edit, view Word document online within the web browser without a user having an application. A non-professional user gets to use this service for free by signing in online with the Google username and password. But I'm sure you have very limited time and the storage space. Once logged on, the user can view documents such as Microsoft Word documents sent to their email with the browser, blah, blah, blah. You can list a lot. Challenge of using software as service. Even though cloud make deployment of large-scale application easier and cheaper, it also creates new issues for developers. Because cloud infrastructures are distributed, application can be deployed in different geographical locations. And the chosen distribution of the application impacts its performance for users that are far from the data center. They said, okay, that's the challenge. Probably now is much better than before when I write this PowerPoint. So that's the conclusion. This module focuses on cloud computing service that include the storage, software as service, and cloud computing operating system. The scalability of this service makes the cloud different from current design. Using various services can prevent a more robust computing environment that can lead to smaller internet-based companies, easier user interactions, and reduce costs in company infrastructure. Combining scalable storage service and backup support is lead to a more powerful computing environment. So cloud computing provides a lot of advantages. People use it very widely today. That's the end of this module.